I'm Jared Ficklin from Frog, and this is our RoomE. We wanted to look at room-size computing, so we bought a bunch of equipment. We've got some Kinects, some ultra-short throw projectors, and in here we think by making, deliver by demo, and think about new interaction models for this notion of a computer that surrounds you. We started with voice, and there's an interesting thing we found about voice pretty early on. We tried it in a traditional manner, which might go something like this. Computer, is it dark in here?
Yes, the room is quite dark. Would you like me to turn on light 1, light 2, or all of the lights available?
So that takes a long time. That's what you might call natural language computing. We find it works, it's working really well in concierge computing or when you're moments of divided attention. But there, we kind of discovered there's an uncanny valley for voice. So we decided, you know what, the computer should answer more quickly and cleanly as technology, which might be something more like, computer, turn on the lights. Right? So rather than talking for too long and annoying me like a bad roommate, the lights come on. That's a very quick, clean answer. And that was kind of an example of command computing, which is a familiar thing for like Star Trek, right? You could say, computer, turn off light 3. Computer, turn on light 3. It's kind of long, and you feel like Jean-Luc Picard while you're doing it. So it's not the best system out there. Besides, the commands stack up. It gets so long you can't keep track of what you could do in the room. But then we started thinking, well, if the computer can see us, we could start handling this the way that people handle it. If there's more than one person in the room, I would look at you and say, go turn on that light. So if we apply that kind of social mimicry to the system, we get a more intuitive and elegant form of computing. We'll call conversational computing. It goes like this. Turn off that light. Turn off that light. Turn on these lights. Right? So now I'm doing things the same way I would do it if it was you and I in the room. It's very natural, it's easy, and it's intuitive. Right? Also, we could pick up just gesture, because not everything requires voice to do. So some other attributes about a RoomE, other than home automation, are the notion that it is pervasive and around you. So it offers you like a heads-up environment. I didn't have to pull out and unlock my phone in order to turn the lights on and off. But it also might involve other things, like a more cooperative or markup of the physical world. So like imagine you're in a conference room. If you were to walk up to this thing, well, it can see me, so it can recognize that I'm here. And it can start solving the two problems that happen at any meeting. So it gives me my calendar invite, letting me know that I'm at the right meeting, and it doesn't recognize me by face recognition or voice, so it's asking me who I am, so I'll tell it, Jared. I know Mike and Mark are on their way. Next thing that happens is you tend to set down your laptop. It knows I'm a guest. It's giving me the SSID and the password so I can log in. And it knows where my laptop is. Maybe I could draw files to all this kind of stuff. So this kind of markup of the physical world is really helpful. It brings the computing things that happen on my phone out into the environment in a way that are very easily and casually accepted. It's my digital lifestyle in the physical world. Now, a lot of this is enabled by projection, and you'll notice we're going down onto a table, and we've learned some curious things about light, right? So I'm going to do another kind of cool home automation thing. I'm going to invoke the backyard. I'm going to see through walls, right? So show me the backyard. And so now I have a whole picture, camera image, show me the backyard. I can see the roofs of my neighbors' houses. But notice what happens with the light here. People in light are a little weird. When you reach into light and it gets on your hands, you feel like you're interrupting something. If you set something on the table, you feel like you're on the screen. But if we mask the light out from an object, it actually sucks the pixels down in the table and makes it a lot more intelligent display. So what we're using here is computer vision to track and recognize options on the objects on the table. And we can extend this even to getting your hands and your shadows out of the way. It makes it feel a lot more like a display. Hide the backyard. All right, so also, there's a lot of moments in computing right now where you kind of frustrate. You go through too many layers of lock screens to bring up something that anyone could see. And here's a good example of that. Rather than bury myself through 3 screens, I could just say, show me the weather. And it brings it to me right where I'm looking, right? It knows where I'm looking, so it puts it there. Make it colder. Colder. Also notice how projection, when it's just doing simple blocking numbers, is way better than when you're trying to do high fidelity images, meaning that I don't have to worry about having a special screen. I could even have that show up right here on the lamp, and it makes it a lot more powerful than output mode. All right, so another thing about an environment like this is things can be a little cooperative. So this is a common scenario where you're all together and you decided to get some food for your gathering. Let's order takeout. So normally what you're doing is pulling out 3 smartphones and beginning to search Yelp. Here we can see the whole list together. It's being curated based on everyone that's in the room. And maybe we can't really decide, so what did I order last time? Yeah, order that, right? But it's doing this, the services are now coming directly into our environment quickly and in a fashion where all of us can participate at once without having to burrow into a single screen. But it's also paying attention to my context. So it knows all devices in the room, and they're all acting as a single computer. So I'll come over here and do the same command. Let's order takeout. It knows I'm over here, so it gives me the list. So now I'll come over here. What did I order last time? The system knows I'm over here. It presents me the data right here. So now the computer really is an envelope all around me. Order that. So another interesting thing about a RoomE is it's going to provide a lot of ability to close gaps. Like experiences now that take 3 or 4 steps could happen a lot more elegantly with a single step by dividing it in areas of the room. An example that would be like this. So I'm here, I'm reading a tweet on Twitter, and I say, reply to this tweet. This video is awesome. So you'll see the input field is right here on the table. And I can type with voice, this video is awesome. Send. I've actually saved my context here. It feels really good and elegant to be able to do that. Not only that, but you could think of group Twitter accounts and co-authoring them together, because I could say the first sentence, you could say the second. That would be cooperative, heads up, and use and mark up the physical world. But probably my favorite small gap in this system is just something like this. We all have found ourselves on the edge of the room before debating how much energy or time or money or pride it would cost us to go over and turn off the light switch, or just to walk out and leave. But in a system like this, you just say, goodbye. Small gap, big value. That's a tour of our RoomE. We continue to work on it. This kind of stuff is going to be foreshadows the next pattern of computing, and we'll be entering our lives soon. I hope you enjoyed it. Bye.